Love you. Like, for the invitation. Thank you. I'm very happy to be here and congratulations to your school, Dean, and your activities. I think that we think in our school that if we take together theory and practice, the architecture could be a great architecture. So we make a small experiment at the end of our experience. You could see if the dome works or not. But just to make a small presentation, I'm a full professor of architectural design in Polytechnic School of Bari. In Italy, we have only 3 polytechnic schools in which architecture is linked. Bari is the only one in the south, and we have 2 in the north, Milano and Torino. So our our education is morely between engineering, architecture, art, science. So just to make a description of our institution. And I'm also the coordinator of our PhD course in Faculty of Architecture in our school. So we hope to create some exchange, Erasmus exchange with your school, but also PhD exchange using different kind of instruments, robotic laboratory to exchange between our institution. So my formation, my specialization is linked to the discipline named stereotomy. Stereotomy. I don't know if you know what does it mean, stereotomy. If you don't know, I will try to explain the discipline. It's very ancient discipline, and the term stereotomy is linked into Greek word, stereo and tomia. Stereo is, we will see what is stereo, is like solid, something solid, strong. Tomia is the cutting. Atomus is something that we cannot cut more. Atomia. So stereotomy is the art of cutting solid material in order to build architecture, specific kind of architecture. And for the material, in the traditional way, we can imagine stone and wood. So in the treatise of stereotomy, and the treatise of stereotomy are most French, the treatise of Spanish between the Renaissance period, speak about stereotomy of stone and wood. Okay, so it's the art of cutting stone or wood to build architecture. But if we start very quickly on the origin of the etymological origin of the term stereotomy, we can easily say that the term stereotomy, the discipline, is linked to the construction of vaulted space. So the art of building vaulted space is linked to stereotomy. And my PhD was linked exactly to study the origin and the evolution of the ancient technique. So I think that the very first imagination of the human being was the observation of the sky. Observing the sky, we had for the first time the idea to build something like sky, something like starry sky. And we will see also from an etymological point of view why is linked to the observation of the sky. I think that one of the first real origin of the logic of stereotopic construction comes from the burial chamber inside the pyramid. So if we see the small chamber, we can see that the only stone cut in order to create the sky, the upper part, was designed with a series, always like this, of stars. So we have a sky design drawing on the stone, and the body of Nut, the goddess, is represented always like a body curved to cover to protect the people, in which inside is full of starry sky. And in a Jewish and Christian tradition, we observe that the representation of the world, the well-known world, would divide in two parts. The upper part is what we name firmament, that is in Latin firmament, and in Greek the term was stereoma. So the term stereoma, which is the origin of the stereotomy, is the part of the starry sky, solid and integral. And so we can say that the term stereotomy, how they may say, composed to two Greek terms, in the part of stereo is linked to the firmament, the solid star in the sky. So the idea was to realize the very complex representation of the sky on the earth. So stereotomy, in the other hand, is also eco-friendly, ecological, ideal for human life just because it's made by natural materials. And that it was very important for imaging to reactualize the discipline nowadays. If we want to start to the masterpiece of stereotomy in the world, obviously we have to look at the work made in the south of France, in the tradition of a masterpiece of stereotomy, is a tradition of South of France. Here we are in the center Hotel de Ville of Arles, in the city hall of Arles, and you can see the complexity of realization of the sky of stone, the solid sky of stone, made by using the technique of stereotomy. And that stereotomy lays together the capacity to imagine the sky, the space, and also the way to design, to draw it, to cut the stone in order to create the complex molded shape for the architecture. So here you can see one of the most beautiful masterpieces of Jules Hardouin-Mansart, the one famous architect in history. And you can see the complex shape, the intersection of the shape of the vault, made thanks to the knowledge of the discipline of stereotomy. So the knowledge of stereotomy at that time it was made by oral transmission. So only by oral transmission in the first time, and after became something to be brought in a book, in treatise, and some treatise was named the secret of architecture. So something linked to the secret and initialization function to be learned. But we can also have some vertical connection like helicoidal staircase, very complex shape made using the logic of stereotomy. In this case, we can see the complexity of the shape of the geometry and the cutting of stone. You can imagine that at that time there was not computer, there was not 3D modeling, no CNC machine, no robotic machine. You can imagine the complexity of the technique in order to build such a beautiful and wonderful masterpiece. Here we are, for instance, in the center of Paris. We are in the church of Saint-Sulpice. You can see some kind of flat vaults, something completely flat that really statically strong just because the knowledge of stereotomy, the way to cut the stone in order to put all together and to be assembly in very easy way. And at the end of stereotomy, we can see the skew bridges for the railway made by a complex drawing of the shape of each block named ashlar or voussoir in order to realize a skew bridges which are some kind of barrel vault in oblique way made a design in, you can see, in a very complex shape. That was the last part, last light of stereotomy leaked before the arrival of concrete, steel, or other kind of material. Or we can see also some real complex shape for angular or helicoidal staircase, which we find also in Mamluk architecture. So you can see also some kind of complex shape which are defying the gravity. Or we can also imagine the stereotomy as the technique to realize cantilever structure in stone, because normally we imagine the cantilever structure also only made by concrete or steel. But if you know, if you can be able to see what in the history it was made using stone and using the technique of stereotomy, you can understand also that it's be easy to realize cantilever space using conical vault or spherical vault of complex double curvature shape using stereotomy and discipline of stereotomy. So that was the origin of stereotomy that I synthesized in very few slides. And now I want to show you our work about the reimagination of stereotomy, reinventing traditional stereotomy. Here, every time I start with one prototype that was my inspired prototype when I was a student like you. Here we have the picture of the president of Italian and my professor, the founder of the School of Architecture of Bari, and Professor Claudio D'Amato. That was the first to imagine that nowadays it's possible to continue to build using stone for contemporary architecture. So starting more than 30 years ago, we stopped to imagine to realize housing or other kind of structure about typology using natural stone and for contemporary architectures. So that was my first inspiration. I was student, I saw some kind of prototype, and here is something like traditional with vaulting space, but inside we have post-station cable just to answer to the earthquake problem that we have also in Italy. And starting from this idea, that was my first realization, my house, my personal house. I was a young architect, and so I imagined to make a tribute to my master mason of south of Italy, which actually nowadays continue to build using those kind of technique. And I realized my house under this big vault made in a traditional way using limestone of my region. That's the name of the vault is Star Vault. So every time the idea of starry sky, the idea of stereoma, the firmament, arrive late to the idea of building the vaulted space, the sky of architecture. So inside is like this, and outside is typical of my region in the Puglia, something very anonymous, to say, in exterior part, a complex in interior part. So that was my first experimentation, my house, using natural materials. Everything is natural, no other kind of chemical material. But our experimentation in university start from this pattern. That was the first pattern that we were working 25 years ago. So if in 1699, the Marseillais engineer Giuseppe inventing a patent, the system to build flat vaults, completely flat vaults, using the same block, which is actually a portion of tetrahedron, thanks to this geometry, she was able to realize a completely flat vault. The references to the Platonic Sodi platonic body, and the idea was to interlock the identical convex polyhedra in order to create the complexity of the aggregation and the population in the space. So if we analyze the different way in geometrically to assemble it together, we can easily understand that the configuration of material is linked to the stereotomy, because we are solid, we are cutting of material in order to transform the basic solid in complex solid. That was the experience linked to the flat bolt of Abbe. So if we take, if we start with the one only tetrahedral geometric basic geometry, we can assemble the space and we can obtain a flat bolt thanks to only one geometry. Also, if we take the cube, we can realize the same flat balls using simple cutting of the basic solid. So we start making some kind of 3D modeling in this discrete element just to understand the mechanical behavior of the geometry and to understand the complexity of the shape and the behavior of the vault. And immediately we start with the realization of the first prototype. And here you can see some kind of picture of the sequence of the realization. Very easy realization. We start from a parallelepiped. We take the inclination of the machine. We cut in easily way from one side to the other side. And once all the blocks are ready, we start to assemble in a vertical way and horizontal way. And in a very few time, everything is ready. We need the border part to take the pressure of the stone, and we make the first test of crashing test of the vault. It was very, very hard to destroy the vault. So what we learned about that? With natural stone, with natural materials, is easy to realize a flat vault without no steel, without no concrete, without no material that create the pollution which create the changing of, the climate change and so on. So starting from this first experience, we try to put together another idea, the flexibility of the shape, the flexibility of topological manipulation of the shape. So we try to make stereotopical body using topological geometry, deforming the shape. So that was the first experience. We tried to imagine what would be done if we take the flat vault and we bend like cylindrical way. So obviously, if we bend the flat in cylindrical part, we have two different geometry. In the flat, we had only one geometry. In the cylinder, in a simple curvature, we had the basic geometry. And that was a prototype that we assembled in the Biennale of Architecture of 2006, exactly 20 years ago. Then was the portal of entrance gate for the City of Stone, one exhibition in the Biennale of Architecture. So what was the interest of this experimentation was the idea to create a vault, a barrel vault, very strong, thanks to the shape of the junction of each blocks. And the pillars were pre-stressed by force tensioning of the cable. So in only one way, we take together geometry, decoration, because also the complexity of the assembly was imagined like a natural decoration. Geometry, decoration, structural behavior, all linked in one way. So that was the idea on which we are working all time. You see, only one way to put together engineering, mechanical, statical, and decoration. That was the important part of disassembling of the century, what we will do in the next 2 hours. So once all the blocks are assembled together, we can remove the centering, and finally everything works. And I was only always the first to go on the top just to say if everything was great. And the city of Venice asked to make some proposition of bridges because nowadays also in Venice, if we want to make new bridges are only in wood because the stone we are not able to make in stone, and so we design a bridges using only stone and post stationing by transversal way, and that was the proposition. And starting from this idea with students, we start to reimagine contemporary architecture, contemporary space using natural material, using stone. So thanks to the programming, some software easy to use, we start to imagine some new configuration on a vaulted system, you know. Bridges are also changing the shape of playing with the pattern of a bay. We try to imagine the possibility to change the basic shape, the basic pattern for the population of full-scale vault. So we make a lot of experimentation during workshops. And for instance, the idea was always to arrive to achieve the complexity using only one block. The question, is it possible to realize complex wall, complex shape using only one block that we can reiterate, reimaging inside the system? So every time we imagine something, we realize to test if it's possible or where are the problem. And once the complexity is achieved in a very easy way, the students start to imagine some new vaulted space, for instance, for a terminal bus, in which the complexity of the geometry is not only linked to the interior part of the vaulted space, but also to the exterior part. And also the topic of porosity, which are something not very strong linked to the tradition, is one of the topic of our experimentation. The capacity for the light to enter inside the block. So we imagine to work always in the same time from mechanical behavior, structural behavior, and geometrical and decoration all mixed together. So here, for instance, some kind of proposition for metro station or other kind of proposition. Here was a project that we developed using the imaging of Turkish bath. You know, how it could be possible to realize some porosity of the vaulted space for spa or Turkish bath for the future. And the topic of porosity for the light or for the other kind of situation was one of our main topic. For instance, here you can see a simple realization of wall using the same logic, only one block, only one geometry to create the complexity. So the complexity is given only by the comprehension of only one geometric ashlar reassembling in the system. So here we have, for instance, a variation, linear variation of hexagonal pattern and curvilinear variation. And another kind of topic is the sign of the realization, because obviously it's not realized by hand, it's realized using CNC machine or robotic machine. So the idea to have the trace, the sign of the machine for us is very important. Another experience, interesting experience, was to turn the barrel vault, the cylindrical vault, in spherical vault. So another kind of complexity on the system. So we start to make some topological variation of the hexagonal pattern, but the deformation was possible only for a very small part of the sphere. So we change the approach, we make another kind of complex geometry in which we have a family of different shape. And we make a parameterization of the sphere just to understand how it would be possible to change the whole inside the system. During some presentation like this, the architect of the first minister of Qatar in Doha proposed to realize a dome using this technique. So we make different variation. At the end, you see the different color are the different geometric shape on the system, on the spherical system. So here you can see an upper view of the vaulted dome, and here you can see one picture of the upper part in which the centering was made by foam, and on the foam we make the color of each block and the direction of each block, because each block is very similar. They change from smooth angle, so it's very hard to recognize the right ashlar in the system. So once all the dome is assembled, we remove the centering. Is that the technique, and the vault part is done. And that was here you can see some picture of Mamluk dome that we realized just at the University of Cairo in Egypt. We tried to realize a Mamluk typical shape using the pattern of a base, the pattern of a base. So the same system, but the structure and behavior of the vault is very, very better from the original normal technique to build the speed. Here some picture of the fantastic place in which the dome was built using the local stone. But the experimentation was made also in other kind of topic. For instance, the capacity to create multiple arches inside the vault, or multiple layers, taking different colors of the stone, or interlace the ashlars vault using the pattern of Erwin Howard memorial pattern, you know, in which the stones are interlaced. Another kind of topic which actually was given always from the history was another patent from the Carmelitan Truchet father that was the first to create a variation of the system using not flat connection between the joints but curvilinear connection. That was very, very never built in the life. We never find something realized using this pattern, but the idea was to connect the block using a double curvature shape in order to improve the system. So we tried to realize the same experience using only one block and complexity of assembly. And finally, in Madrid, we realized 2007, 20 years ago, is very, very strong skew bridges that normally for the normal theory of engineering was impossible to be realized, but thanks to the shape of the stone, it was perfectly realized. It was very strong. In this case, each block is different, so the complexity of realization is very hard. We try to also to imagine a completely twisted arch in using the double curvature connection of the blocks, and we realize in Melbourne, in Australia, an experience about that. We start using a complex shape of connection to realize vaulted space, and we arrive finally also to imagine a minimal surfaces in discrete block construction using a complex joint interface of connection. Here, for instance, you can see another kind of solution named osteomorphic connection. So like the osteomorphic body connections, in which the blocks are complex in double curvature, able to move if we have some earthquake problem. The structure can be flexible in stone. It's very straight, but you can have some kind of movement to dissipate the energy. And we obtained the observation of those techniques, taking part of the lecture. For instance, here is sketches of Leonardo da Vinci for an optimization of voltage space of Cathedral of Milano Cathedral. He proposed to optimize the behavior of the arches, creating some kind of osteomorphic connection. So we realized a vaulted space using a catenary shape with osteomorphic block with post-tensioning in the exterior part, and in that way the system was very, very strong, and normally it's impossible to imagine, to realize in traditional way drawing such a kind of shape, but using 3D modeling, robotic cutting, CNC machine, you can easily realize those kind of shape and realize such a kind of blocks. And we obtained the same results during the same Biennale of Architecture in Venice in 2006, because near to the vault we realized an obelisk. Normally the obelisk is monolith, but it was very impossible, very hard to bring a monolith inside the La Serenissima, inside Venice. So we realized the obelisk in different parts, and each block is 2 meters, so it's a very huge block, using an osteomorphic connection, because the obelisk is a flexible structure, so can be moved. And if you see, each obelisk is spread related to the corner. So thanks to the movement that actually the connection, it can be done with the movement. Thanks to those kind of connection, everything works very well. And here you can see the blocks, and the obelisk was perfectly assembled. Here is another kind of topic, but it's very complex because we use the vacuum system to glue together the blocks. That is a kind of experimentation that we can do in easily way. The idea was to create the connection, the gluing of the block using the vacuum. So if we imagine to realize some kind of special vacuum inside the blocks, between the blocks, we can create easily the vacuum, and we can glue in very easy way the stone in order to be assembled without centering. And the idea to create the best connection between the arch for earthquake, for avoid the possibility to use centering, comes from the history. Always we are linked to the history. We are obsessed for the history. So you can see the Mamluk construction, or the Islamic pattern presented some kind of arches or plate-bound like this, with convex shape. So the idea was to realize a more complex shape, more complex interface between the blocks using this kind of drawing. What is this kind of drawing? Is something linked to the idea to connect together all ashlaks. Why? First of all, to try to avoid using of centering, because if we are able to calculate to have each block assembly without centering, we can also not use the center, but we can also make the structural behavior of the vault not only in compression, but also in tension for earthquake situation. And we realize, if you see this picture starting from the bottom, we realize the shape we designed, the shape of this art, in order to be assembled without centering. That is very important for us. To avoid the centering is very important. So, and once everything is done, we make some tests of cracking of the stone. Is completely, these are my student of PhD student, So if you enjoy, you can come to make some kind of dangerous thing in our lab. And the idea was really to realize an arch completely without centering and very strong intention and traction. So that was the last experimentation that we are working on. Try to make also some kind of different mortar using the waste of powder, and that was one of prototype that we test, and that is something perfect for earthquake situation. And here, working in real scale, I realize in earthquake headquarter of a company, French company, which is very well installed in the Troyes, in the city of Troyes, in the region of Champagne. And that was the headquarter of the company of the society SMBR. And we realized something very simple, and parallel arches in stone. In French, it's not possible to realize the foundation in stone. Is not permitted. So only the foundation is in concrete. I don't know why, but that is the rules. And each arch has 60 meters of dimension. It was assembly very easy way. One arch in one day, assembly in one metal structure that could be moved in a perpendicular way from the arch. And you can see the blocks are very huge, and the centering is assembly on metallic part that could be moved in very easy way in order to realize the fullest building. So here you can see some picture of the realization. The holes are the barycentric part of the volume, the centroid of the volume. So thanks to this configuration, we can easily move the blocks, also huge block in very easily way. And the junction are not flat, but are linear. And thanks to this shape, it's very easy to be assembly in the right position, only thanks to the gravity of the stone. So no any kind of energy to realize the building, to realize the arch. On the top, only natural material, wood and stone, and that's the interior part. And the company works in the space only made by natural material, using stone, wood, heart. And they asked me to realize a portal of entrance gate for the building, and I design an hyper gate. Hyper is the geometry of the gate, and just thanks to the particular geometry of the hyper, which actually is a configuration of rules to surface, we cut each block using a robotic head made by diamond cable, able to cut in a robotic way each kind of blocks. So here you can see the experimentation that I make from only one part of the system, and the realization was made in an easy way using a centering made by a series of linear metal bar, and each block are posed in the perfect place. And once everything was made, inside the joint was made a bar and post-stationing by pre-stressed by post-stationing of the system. And starting from this observation, we start to realize this is the grandmother of our experience that we had here. So what we did, we cut a small block of hyper brick, hyper small block, hyper boussoir, starting from only one block of material, we cut without any waste of material. So we cut a lot of bricks, starting from only one blocks, only one parallelepiped. And once that is done, we can remake in a new configuration the blocks. And thanks to the reassembly of the block, we can create, using the same block, a sinusoidal wall, or using the same position or linear walls. So that's very interesting because we start from one parallelepiped, we realize some kind of bricks, only one kind of bricks, and we reassembly in order to create new configuration of the space. We presented Magma Mark is one of the most important fire in the world for the stone construction, and we also had the possibility to show the prototype in Piazza delle Erbe in Verona, in the city of Verona, and it was very appreciated because nobody tried to vandalize, to try to destroy the prototype. And the idea was, if it's possible to realize a sinusoidal wall, obviously it is also possible to realize the barrel vault using the same system. So we create in the same logic a vaulted system using NIPAR blocks, which is completely linked to the idea to the realization of the sky, birds with some strong part-like stars, you know. And here you can see some picture of the realization. And just because if you want each single ashlar is like a torsion block, you have inside one axis in which it's possible to put a cable, a safety cable, and you can also pre-stress the system by post-tensioning of the cable. You cannot see in exterior, but here you can see the place in which you have the post-tensioning inside the block. So you can make more stronger the system using the post-tensioning of the block. Here you can see the light inside. So stereotomical construction are paradoxically a paradox because they use hard material in order to make something light, something very aerial, something light, you know. Here we try to realize also spherical version of the hyper once system. So here you can see the dome making the same way, and you can expand the architecture starting from the optimization of the blocks. So the idea of optimizing the material in order to realize some vaulted space is at the base of the reflection about the stereotomy for nowadays. And the idea also to the transportation, the stackability of the material is very important. You can stack together the blocks and you can easily transport. And starting from those ideas, the blocks that you are here, that we are assembling now, is the daughter of this system. So if we start from one block, we can use a curvilinear system. We can also cut with some kind of robotic way in order to optimize all blocks. And if you want to play with the same block, with the same unique block, you can make different kind of composition. You can make a wall, you can make using only one block, and finally you can make the vaulted system, which are now all the sinusoidal system, or you can make the expansion of the barrel vault system. And finally we realize in different way the blocks using the same system that you are using now, so molding the geometry, and the first was made by 3D printer, and molding the system you can have the same blocks completely stackable, and you can assemble in a different way. And here just the same operation that we are doing now, but just to show you what we have done with our student. If they are student of PhD, so assembling in very few time, 10 minutes, everything is made, and we can remove the century. And once the century is removed, the system is completely the light that side. The name is multi-obvious vote. So you can see here some picture made with and from the I'm arriving at the end, and from a realization, stone realization point of view, we can realize using different kind of technique. For instance, if the stone are very hard, we can realize using some kind of CNC machine to cut the stone using the circular method, but could take a lot of time, or using the robotic linear cutting time on the cable is possible to cut without waste of material. So that could be the real method for optimizing the optimization of the realization. And we are studying now something which are very interesting for us, the robotic assembly of the boat. Thanks to the stackability of the stone, thanks to the fact that we have a hole in which the end effect could be taken, we can easily make the programming of robotic assembly. So here we have the traditional way to build a vaulted space, because they are in compression only, using the robotic machine, because we think that the future of stereoatomic vaulted space is linked to the robotic assembly. That is a very simple assembly because it's a cylindrical wage, but in the same time the problems are very hard to solve, because the end effect of taking of the block, a lot of the crash test between the blocks during the movement, a lot of problems are coming. So here you can see the variation in some solution, and that is the solution for Smirne. So if you want, that is a romantic solution with still like a Viollet-le-Duc system, like in a principal square in Smirne. So we can imagine some kind of vaulted space using those kind of machine, not just because also the design of the shape is very linked to the tradition of Turkish traditional drawing and patterns. So in the floor you are the pattern of. And also I seen yesterday the drawing of a wave during the walking part. And if we want to imagine something more strong for the earthquake solution, we can imagine that also these kind of blocks, thanks to the fact that could be perforated in this part, can be a post-tensioning, pre-stressed by post-tensioning. Here we are moving also to another kind of solution of the post-tensioning, the gravitational post-tensioning. The slabs of the soil is the mass which can give the natural post-tensioning. We realize different kind of solution on that. And here, but this is a very mechanical, engineeristic part about that. We realize with stone cantilever, different kind of cantilever structure, a lithic tree in solution to realize the branches in cantilever in order to realize also some kind of architecture contemporary architecture made by stone. We realize also we design with the idea of cantilever structure, acoustic shell of theater for conferences, using a small part of steel and the right stereotonical design of the blocks. Also, on the joint connection, we work in order to avoid the possibility to the creating the centering using some kind of steel connection, which could be holded in the space, entering pressure on the same time. Here we are in the exhibition in Lyon, Rocalia, or Strasbourg, because it's very easy to imagine to assembly and disassembly stone vaulted space in different parts of the world. And at the end, he arrived at the last Biennale of Architecture in Venice, at Giardini delle Vergini. We realized also some kind of lithic frame. Here some romantic picture of the realization. The last part, closing. Using the stones, obviously we can create some waste material, but we can reuse the powder of the waste material to create mortar able to be 3D printed. So we are working on the stereotomy in 3D printed using waste of material, so no part of the stone to be rejected, you know. So we realize bridges in which the stone are stereotomically conceived, and we are also working on some kind of vaulting space using ashlar in minimal surfaces. So we work a lot of crushing tests of each minimal surfaces block, and we work also to realize some 3D printed block in minimal surfaces in order to realize robotic fabrication, crash test, and stereotomical bolts, stereotomical bridges, stereotomical bolts in which the ashlar are in minimal surfaces, the stone are inside the mortar, and that was one of the last realization we made in Macomac with Vertico, a company, Dutch company, leader of 3D printers. So here you can see the same technique of construction. And finally, stereotomy, modern stereotomy for our research is something always related to the starry sky, to the idea to build on the earth the sky inspirationally from the firmamented stelloma. Thank you for your attention. Here we are, as William Barry, our landscape is completely made so you are welcome.
Excellent, Giuseppe, for very nice presentation showing all your work and how stone can be used in different ways and not only just doing straight walls and so on. So, is there any question, please, to Giuseppe?
I want to ask about this hotel that the education process of your beers get the preparation and short as yet can you get the structure process and it's some kind of specific general piece. I also want what is your lectures the process is going the starting point and the way. Hyperstereo beats opens by how good is how you get
In your university?
Yes, in my university, stereotomy was a topic which actually we start from the first year, the second. Each year we make a small part of stereotomy because the knowledge of the global discipline is very, very huge. So the learning, the didactic way to learn about stereotomy and learn about the way to build those kind of structure is very intensive each year. But the most important focus is done during the PhD. So we had a lot of students of PhD which actually started to make stereotomy in theoretical part and also in a practical. And the practical part is linked to the company, different company in the world. So this is a summary, a such synthesis of a complex work that we make we made in the last 20 years, 25 years.
I don't know if you will, yeah, knows which software they are using.
Which kind of software? We start using different kind of software from a mechanical point of view and from geometrical point of view. We started 20 years ago using AutoCAD 3D, 3D Studio, Maya. That was the geometrical part. Now is Rhinoceros, Grasshopper. We work on that. But from mechanical part of view, we use Abacus, we use 3Deck, we use the software mostly to engineer, mechanical engineering and geological, mechanical, des ingénieurs des roches, geotechnical engineering. So, we cannot find only one really useful software for everything. And we need to make one-to-one full scale to make the comparison between the results of the software and the real results. Because you can make the same boat, the same arch, but if you change stone, if you change the place in which in the quarry you change the stone, you can have different behavior, different kind of final solution, you know. So it's a world in which you are very focused in engineeristic way to see the problems, but also artisanal way to see to solve the problem.
Thank you very much. Very inspiring presentation. Your host reminded me of an Italian structural designer, Nervi. Nervi, because he tried all these small seats, made Posco. You big stone. Did you have some sort of inspiration, or did you look at
Nervi, the original Nervi. Yeah, absolutely. Yeah. Thank you for the question. Yeah, in our culture, you know, we learn about a lot about Nelvi, Sergio Busmeci, with the minimal surfaces bridges. So we have a part of the past engineering culture very strong, and we are referring, to the study of those big master of the engineeristic study. Yeah, absolutely.
very similar, not only structural, like aesthetic accessibility with the traditional methods?
Yeah, absolutely. Yeah, seriously.
Yeah, thank you very much for me. Was inspiring. I just reminded of some important conversations for the pictures and from history, architecture. So one of them was from Isabel Cardino and very famous from Isabel series, a very famous conversation between Marco Polo and Tuglarhan. So Marco Polo was answering to him, like Tuglarhan was wondering about the curvature. However, Marco Polo was just telling him about the sport, but he was just insisting also, okay, tell me about the curvature, and he was just saying without the sport, they go furniture of the arch. So, but I just first try to understand with the pieces that you have made. I also divided of Greek's question to a Greek. By the way, I asked Greek, what do you want? And Greek answered me, I love an art. So actually you are interested in both of them, as far as I understand. So there are curvatures and curvatures, right? That stone is also becomes kind of, say curly like it, you can just provide them with. So what is the motivation behind? I also HSC researcher. With the phone, we catch the message area that we would have out of the arch and the arch itself and the parts of force and the curvature inside the parts. There are all, very complicated. Complicated, kind of. So what are the motivations or what are parameters defined? I was just wondering you on what this listening to this very last presentation.
Thank you for the observation, for the question. Yes, these two sentences that you say are the most important. And Italo-Calvino country are always present in our discussion. The question is complex because make an arch would be something very easy, very easy, because we try to make the first year experience with students, and they ask the student, they show how to build an arch with brick. They say, okay, you could realize very easy way, and it's like that. They can realize also if the arch is not perfect. Once it's assembled, it's very strong, and nobody knows why it's strong enough. We make also a test with some professor of structural engineering, and we say, okay, you are engineer structure. What is the load that the arch could be before the crushing? And actually, you can. They say completely different value. So in the world of the computation of stone arches of vaulted, is very hard to find to have some very good professor able to say to you what is the final load that the vault could be resist before the crashing. And it's not only for the curvature, because inside the construction of the arch or vault there are a lot of parameters, and the matrix of parameter is very enormous. So you cannot easily say what is the problem in which, because you have the mortar, you have the brick, you have the quantity of the brick, you have the curvature, the optimizing of curves, the dimension of the shape inside the shape. So it's very complicated, but in the same time it's very easy to realize. So you have a paradox, the very easy way to realize and the very complex to analyze. So in this big difference between the two parts is the mystery of the arch, somehow. So what I think is that from didactic point of view is, for me, is very important to teach to the student to build arches, because really you feel a lot of sentiment, the material, the way to build, the geometry, the potential collapse of the structure, because you cannot, and that is like exciting part of the blade, and all those parts is not present in steel construction or in concrete construction. It's not the same. Once you make your frame of peripheral steel, everything will be fine, but in stone discrete arches construction is completely different. So from academic point of view, starting also from the sentences that you make, you have like a poetry in a construction. So I think that those parts in a didactic way is very important, because perhaps you will never build in arches in your life. But if you make this during the period of university, you can bring with you a different kind of soul experience. And for this reason, I talk every time about that, about the possibility once in the life to build an arch. So I hope that everybody of you could make this experience because it's very rich of sentiment, you know. And if we want to talk about scientific, we can stay all the night to discuss about the curvature, the direction of the joint. We enter in a very complex discussion. So you can have the discussion in very simple way, in very high way, in the same topic. So that's this exciting, it's stereotomical discipline for me. Thank you.
Last one. Thank you very much. It was really very clear and very inspirational and amazing lecture for us. And I really appreciate this connection between theory of it and the practice of it, even at a PhD level. So that's very, very inspiring for us also from an educational point of view. And throughout the images, I was thinking which stone, I wonder which stone is this, which stone is that. So you have a technique and you have material stone. But then there's this question of which stone, what is the soul of the stone? Because granite, for example, is a very hard one, and limestone is a very soft one. So I wonder which comes first. I mean, do you have the stone in mind first, then you go to the form, or form first, then you go to the stone? How does it play
Yeah,
out?
that's very great question because normally in the history of stereotomy, never was used hard stone or graph, but soft stone. Why? Because it is a question of pressure. If we use soft stone like limestone, 2,4 or other kind, the pressure is compensated by the irregularity. Because when we cut the joint, if the joint are not perfect, you can have a focalization of the pressure. You can break the stone. So soft stone is the best one to realize vaulted space and is the most appropriate stone to realize stereotomic shape for the vaulted space. But in the history, obviously, we can also find some exception. If you have the possibility to see in Madrid, near to Madrid, Escorial, El Monastero del Escorial is a huge historical construction made in stereotomical way, in a very perfect in granite. So it's something exceptional, but it's only the exception, you know. Normally we use soft stone for the vaulted space. For the arches you can also have hard stone, but hard limestone. I don't know if you know the church of Padre Pio in my region, made by Renzo Piano, with the hugest arches in the world. Is 40 meters of arches. Is used limestone, but hard limestone. So normally we use soft and hard limestone, but soft stone for the vaulted space is the best one. But for the wall, we can change the material because other complexity. For instance, the upper part is hard stone for the humidity, for the water, or the vertical part you can change the material. So if you go in Paris or other kind of country made by stone, you will see the different kind of stone is made not only for different colors, but because each stone is perfect study, analyzed for that kind of function. So that is also another kind of very good didactic way to teach the historical construction, because you can find color and specific stone for each part of the building. And that is very important, because nowadays we are able only to see that color is good, that color is not, only choosing the color of material, but the color is linked to a specific quality of the stone, a function of the stone. So you can have different kind of stone for each specific part of the wall, but normally the vault is soft stone. And because also it's easy to cut, it's easy to realize. So the stone is very important. And I'm the art director of an exhibition in Marbomac, and near to our cultural exhibition is each September is a huge area with a lot of Turkish company. So you had a lot of company which are very interesting to architect. We could be able to work with stone. So I think that could be a very opportunity because the company of stone, they are rich because they take stone, but they need to have people able to work with stone, to make experimentation, to make stuff, to make different prototypes, obviously to sell, to make a business, but also they are happy to see how it's possible to use their own stone to make a monument, to make a prototype. So I think that if you make some kind of connection with the world of Turkish stone, could be some very interesting stuff to do with students, because they give you for free material. They say, okay, try to do whatever you invent. For us, it's like this. They call me every day, I will find this stone. Do you want to make something? Invent you something. So it's something very interesting to approach.
We have Michael Fair here.
Yeah, the back of the Turkish.
Michael Fair is a big thing, isn't it?
Yeah.
Capital March.
Yeah, so I'm sure that also the company here has a lot of equipment like CNC machine, robotic machine, but normally they are not very able to use at very high level. So
Is there any other question? Because I know Giuseppe is able to speak and like to speak in hours about this favorite topic. We spent an evening together yesterday. It was very interesting. So on, and we'll be able to continue, but there are some other workshops going on. And we have a vote to finish.
we have to give.
So do you have any other question, please? You can ask. If not, we will finish.
If you are not interested, I can. That's out the book that we wrote. I can give you the PDF of the book if someone is interested.
So you can contact.